So in this example, we can see by the description we're going to be using a Venn diagram, something we talked about back in Unit 2. Results of a survey in school newspaper stating that 62% of students skip breakfast, 24% skip lunch, but 22% eat both breakfast and lunch. So first question is, are they mutually exclusive? Well, can you skip breakfast and skip lunch? Yes, you can. So because both events can happen, these events are not mutually exclusive. B and C, we're talking about the probability of randomly selected students doing specific things, and we can't just go with the percentages the way they are. Because if you look at them, they're not set up in the same way. The first two, 62% skip breakfast, 24% skip lunch, and 22% eat both breakfast and lunch. So in order to deal with this, we need a common reference. So the easier way to do this would be talking about which percentages eat each meal. So we have 38% who would eat breakfast. We would have 76% eat lunch, and 22% eat both. Now that we can look at it this way, looking at that, if we add up all the percentages, 38 plus 76 plus 22 does not add up to 100% at all, meaning some of these have been double counted. Looking at this, with a Venn diagram attached to it, we can talk about the two events as eating breakfast and eating lunch. As with any Venn diagram, we have to start with the overlapping pieces first. That would be that the 22% eat both. And knowing that, we can develop how many just eat breakfast, how many just eat lunch. So 38% eat breakfast, meaning our breakfast bubble has to have 38% in it, but since we've already counted 22% for eating both, 38 minus 2 gives us 16% that just eat breakfast. Likewise with the lunch, we know we have 76% eating lunch, minus the 22% we've already counted as eating both, would give us 54% who eat lunch. And now we can determine the percentage outside, which in this case would be the percentage of people that don't eat either breakfast or lunch. We know we need to add up to 100%, so 100 minus 54 minus 22 minus 16 would give us 8% that don't eat either meal. Knowing this, we can answer questions B and C. The probability that a randomly selected student skips breakfast but not lunch. So they eat lunch and skip breakfast. That would be the part, it's just in the lunch section. That would be 54%. C, determine the probability that a randomly selected student skips at least one. Well, what we know here is that this 16% would be skipping lunch, this 54% would be skipping breakfast, and this 8% would be skipping both. So because this question is worded as skipping at least one, we need to take all of those into account, and so 16 plus 54 plus 8 would be 78% who skip at least one meal.